Hi everyone, in this video we're going to talk about the chain rule. First, let's highlight how the chain rule works using this example. We can find the derivative of this f of x equals 3x plus 1 squared by first multiplying this out, foiling this out. We get a 9x squared plus 6x plus 1, and then we can just apply the power rule and the sum and constant multiple rules. This gives us 18x plus 6. The other way to do it is to use the chain rule. The chain rule says that if we have these compositions, then the derivative of this composition is going to be the derivative of the outside function f prime composed with the inside function g of x times the derivative of the inside function g prime of x. And if we have more than two functions that are composed like this, we just continue this pattern. Okay, so applying the chain rule over here, notice I have 3x plus 1 on the inside and this squared on the outside. So what I can do is I can say f prime of x, since this is a composition, is just going to be the 2. I'll bring the 2 down, multiply that by 3x plus 1 to the 1. I won't write 1 there, but there's a 1 there. And then I'll multiply by the derivative of the inside, which is 3. So this gives me 6 times 3x plus 1, or 18x plus 6. And you can see that they're the same. A simple example, but it highlights how to do this. So let's go ahead and use this for more complicated examples. Let's find the derivative of these using the chain rule. So f prime of x here is going to be the derivative of the outside function, which is this to the raised to the 4th power here. So that's going to be 4. Then I'll leave the inside function alone here, x squared minus 5, and that's going to be 3. I remember that. And then I'm going to multiply by the derivative of this inside function, which is 2x. And we can simplify that down a bit. Let me bring the 2 and the x out here to give me 8x. I'll do x squared minus 5 cubed. You can leave it like that. You don't need to multiply that out. For this problem here, I have a square root. So remember, this is 4x minus 3 raised to the 1/2 power. So my y prime is going to be 1/2 times 4x minus 3 to the negative 1/2. And then I'm going to multiply by the derivative of the inside, which is 4. That's going to be 2 times 4x minus 3 to the negative 1/2. Which, if you wanted to, you could just write as 2 over the square root of 4x minus 3. Okay, this problem here, I have this exponential function. R prime of t is going to be the derivative of the exponential, which is just e to the 2t minus 3t squared. Then I'm going to multiply by the derivative of this part here, the exponent, which gives me 2 minus 6t. Okay, and that's it. You can simplify that if you want to distribute the terms. You could have 2e to the 2t minus 3t squared minus 6t e to the 2t minus 3t squared. But that's not necessary all the time. Okay. Here I have an exponential composed with a sign. So I want y prime. Now in this case, this means dy dw, since w is clearly our independent variable. I'm going to take the derivative of the exponential function, which is just e to the sine w, and then I'm going to multiply that by the derivative of the sine of w, which is the cosine of w. And that's it. That doesn't simplify anymore. For this one here, I have a natural log composed with a cosine, composed with an x squared. So I have these 3 functions here. So I'm going to start on the outside. G prime of x is going to be the derivative of the natural log. Remember, is going to be 1 over, and then I'm just going to leave the cosine x squared. Then I'm going to multiply by the derivative of the next function, which is the cosine. So that's going to be a negative sine of x squared, and then I'm going to multiply by the derivative of the innermost function, which will be 2x. So I can put that all together. That would be a negative 2x sine of x squared over cosine of x squared, which, if you remember, would be negative 2x times the tangent of x squared. And that's the derivative. Okay, I have a logarithm here with a base of 6. So s prime is going to be the derivative of this logarithm. Log base 6 is going to be 1 over the natural log of 6 times 3m tangent m. Then I'm going to multiply by the derivative of the inside. On the inside here, I actually have a product, so I have to use the product rule. So I'm going to take the derivative of the first, 3, times the second, tangent m, and I'm going to add the first, 3m, times the derivative of the second, which is secant squared m. And that's it. You could potentially factor and cancel. Notice that we have a 3 common in both of these, and we have a 3 here. So I can factor out a 3, leaving me with tangent m plus m secant squared m over the natural log of 6 times, I'll bring the 3 out here, times m times the tangent of m, and the 3's cancel. There you go. For this next problem, I have a sine squared. The outside function here is the squared. The inside function would be the sine of y. So h prime of y would be 2 times the sine of y to the 1, and then I would multiply by the derivative of the sine, which is the cosine. And that's it. That's your answer. Here I have the outside function is cosine, inside function is the tangent. So y prime is going to be negative sine. The derivative of cosine is negative sine, composed with the tangent of x, and then I'm going to multiply by the derivative of the tangent, which is secant squared of x. And there you have it.